Are you sure we truly understand everything about Earth? Probably not, because sometimes nature creates scenes so strange that even when you see them with your own eyes, it's hard to believe they're real. From massive swirling clouds rolling across the sky, to winds so powerful they blow water backward the moment it pours over a cliff. Even when science can explain what's happening, the view in front of us can still make Earth look like an alien planet. A place where nature unleashes forces powerful enough to leave us stunned. And even animals can play a role in creating some of these rare moments. How many of these bizarre phenomena have you seen before? Watch until the end and tell us your number in the comments. A massive disk of ice sits in the middle of the river. Its edge forms an incredibly smooth curve, creating an almost perfect circle on the water. The Westbrook ice disk appeared on the Penobscot River in Maine, United States, in 2019. It measured more than 90 meters across, roughly the length of an American football field. Most ice disks that have been documented are only around 6 to 9 meters wide. Some people even walked out and stood near the edge. Ice disks can form when a sheet of ice becomes trapped in swirling water. The continuous current causes the ice to rotate, while the surrounding water gradually erodes its edges. Over time, the disk becomes increasingly round. Currents beneath the ice may also contribute to the process. This ice disk lasted for several weeks. During that time, its condition changed with the temperature. After about a week, colder weather caused it to freeze into the surrounding ice and stop rotating. The entire sky seems to drop toward the ground. Layers of dark clouds stack on top of one another, while the lower section curls into a massive rotating structure. This is a supercell over the plains of Saskatchewan, Canada. This type of storm can rise more than 16 kilometers into the atmosphere, while the upper cloud structure can spread across dozens of kilometers. The landscape here is wide and relatively flat, allowing the entire structure of the storm to stand out clearly along the horizon. Inside a supercell is a powerful, continuously rotating updraft. Winds at different altitudes change in both direction and speed, This allows the entire system to maintain its rotation for hours, although it does not necessarily produce a tornado. The movement of a supercell can also be unusual. Some storms can move away from the general direction of surrounding storm systems. When powerful enough, they can bring large hail and extremely strong winds. The sky can sometimes even turn green as light passes through clouds containing large amounts of water and ice. Between mid and late February, a waterfall on the face of El Capitan can suddenly turn orange-red. At first glance, it looks like lava pouring down from hundreds of meters above. Wind can also blow tiny droplets away from the falling water. They catch the light, creating a glowing haze around the waterfall. Horsetail Fall is located in Yosemite National Park, California. The waterfall drops more than 300 meters and flows only seasonally. Most of the time, the water remains its normal white color. The transformation begins as the sun approaches the horizon. Sunlight strikes the falling water, while the surrounding cliff has already fallen into shadow. The illuminated section gradually shifts from yellow to orange and then red. For the Firefall effect to appear clearly, enough snow must melt to create flowing water. The western sky must remain clear, and the angle of the sun must be just right. Even when all the conditions line up, the most intense colors usually last only about 5 to 15 minutes. That's why many visitors wait for hours beneath El Capitan just to witness this brief moment. Thousands of starlings fill an entire section of the sky. The flock contracts into a dense mass. Then it stretches into enormous ribbons. Seconds later, every bird changes direction almost simultaneously. A starling murmuration usually appears around dusk. A single flock can contain tens of thousands of birds, yet there is no single leader controlling the entire movement. Each bird mainly watches and reacts to the birds flying closest to it. As soon as one group changes direction, nearby birds immediately respond. That movement spreads extremely quickly through the entire flock. As a result, thousands of birds can turn together, dive together, then sweep upward again with almost no collisions. This behavior also helps them defend against predators. When a hawk or falcon approaches, the flock constantly changes shape, making it extremely difficult for the predator to track a single target. The display ends when the entire flock descends into reed beds or other roosting areas for the night. Early in the morning in northern Australia, the entire horizon can sometimes be blocked by a long band of cloud. It looks like a tube, low and sharply defined. Several more bands may appear behind it, running almost parallel. This phenomenon is known as the morning glory cloud. Each band can stretch up to 1,000 kilometers, reach around 1 to 2 kilometers in height, and travel at speeds of up to 60 kilometers per hour. What is actually moving is a wave in the atmosphere. Moist air is pushed upward at the front and sinks behind it. Water vapor continuously condenses at one end and evaporates at the other. This makes the entire cloud appear to roll forward on its own. Around Burketown, September and October are among the best months to witness this phenomenon. Glider pilots also wait for the morning glory to appear. They use the rising air along its leading edge to fly beside the cloud, almost like surfing a wave through the sky. The moment water spills over the edge of the cliff, it is blasted back upward. The waterfall breaks apart into thick mist. Some of the water is carried back toward the top instead of falling into the valley. Nanagat is a mountain pass in Maharashtra, India. The slopes here drop sharply toward the lowlands. This terrain helps force powerful air currents upward. The spectacle is most visible during the monsoon season, when heavy rainfall creates strong flows of water across the mountaintop. As the water crosses the edge, it meets air rushing upward from below. The waterfall immediately breaks into countless tiny droplets. The lighter droplets are blown back into the air, making the entire waterfall appear to flow upward into the sky. To see this effect, the rainfall has to be heavy enough and the wind has to be strong enough. Fire burns directly on bare rock. No wood, no coal. Multiple flames continue rising from cracks across the mountainside. Yanartaş is located near Chile in southern Türkiye. Its name means burning stone. The fuel comes from directly beneath the ground. Natural gas seeps through cracks and reaches the surface. Around 87% of it is methane. Once ignited, the continuous supply of gas from below keeps the flames burning. What makes this unusual is that the methane here does not come from volcanic activity. Some of it is produced through geological reactions within the rock. This process has sustained the gas supply for a very long time. The The flames at Yanartaş were documented more than 2,500 years ago. Today, visitors can still hike up the mountainside and stand right beside the burning vents. Many people also come at night, when each flame stands out clearly against the dark rock. In the middle of a snow-covered field, water continues shooting from the top of an ice formation more than 14 meters high. This ice formation appears during winter in the Kelvin region of Kazakhstan. It looks like a miniature volcano, but there is no magma or hot rock inside. The water source lies around 200 meters underground. Natural pressure forces the water to the surface. Each time it erupts, some of the water freezes. New ice builds over older layers. Over time, the cone grows taller and wider. The white material spraying from the opening isn't volcanic smoke either. It's water and tiny droplets thrown into the freezing air. The structure can continue growing throughout the winter. People standing at its base reach only a fraction of its height. This phenomenon exists only during the coldest months before disappearing as temperatures rise. Walking through this frozen landscape feels nothing like crossing a flat field of snow. Sharp columns rise tightly packed all around you. You can encounter this landscape in the high, dry regions of the Andes. These ice formations are called Penitentes. They look as though the ice is growing upward, but the opposite is actually happening. The snow is gradually disappearing. The air is extremely dry, while sunlight at high elevations is intense. Ice can turn directly into water vapor without first melting into liquid water. On the snow surface, depressions receive more concentrated sunlight. Those areas continue losing ice and deepen further. The surrounding sections remain behind and gradually rise above them. This process eventually creates entire fields of sharp ice columns. Over time, the whole surface can become covered with tightly packed penitentes. Their orientation isn't completely random either. The columns often lean in directions related to the position of the sun. A person's shadow appears within the mist, much larger than normal. Around the head, rings of colored light can sometimes appear. The Brocken Spectre is named after Brocken Mountain in Germany. The summit experiences around 300 days of fog each year, giving it frequent conditions for the effect to appear. The observer needs to stand with the sun behind them, with fog or clouds ahead. Sunlight projects the body's shadow onto tiny water droplets. The mist has no fixed surface and is constantly moving. As a result, the human figure can appear distorted, enlarged, and even seem to move. The colored bands surrounding the figure are called a glory. They form when light interacts with tiny water droplets inside the cloud. A similar effect can also be seen from an airplane. If the sun is behind the aircraft and clouds lie below, passengers may sometimes see the plane's shadow projected onto the cloud layer. Rings of glory can also appear around it. One turtle after another crawls out of the water. Within a short time, the entire beach is covered with females searching for places to dig their nests. Ostional lies on the Pacific coast of Costa Rica. Olive ridley sea turtles gather here during mass nesting events known as Arribadas. Some events last only a few days, but the number of turtles can reach tens of thousands. The largest Arribadas can involve around 200,000 turtles. They all dig into the sand, lay their eggs, and return to the sea. Nest density becomes so high that turtles arriving later sometimes dig into eggs that were buried earlier. Arribadas can occur throughout the year at Ostional. The largest events usually take place from July through December and can last 5 to 6 nights. When turtles arrive in large numbers, access to the beach is also controlled. Visitors must be accompanied by licensed guides to minimize disturbance during nesting. The surface of the sea constantly twists into enormous circles. Some whirlpools reach 10 meters across and around 4 to 5 meters deep. One disappears and another forms nearby. Between two fjords near Bodø in northern Norway, Saltstraumen is a narrow channel connecting the two bodies of water. About every 6 hours, nearly 400 million cubic meters of water must pass through a channel only around 150 meters wide. As the tide changes, this enormous volume of water is forced through the narrow passage. The current accelerates, sometimes reaching around 20 knots, or about 37 kilometers per hour. The surface begins to churn violently, creating a series of massive whirlpools. This cycle repeats around 4 times each day. Near a new moon or full moon, the tidal currents can become even stronger. Visitors can also take a RIB boat with a captain onto Saltstraumen and observe the whirlpools from close range. Dust fills the air. The sky turns yellow or orange. The light grows noticeably dimmer. When the dust becomes dense enough, distant buildings and vehicles almost disappear from view. Gobi dust storms originate in the dry regions of the Gobi Desert. Strong winds sweep across the surface and lift huge amounts of sand and dust into the atmosphere. Larger particles quickly fall back down. Smaller particles can remain airborne and travel hundreds, even thousands of kilometers. The scale can become enormous. During the 2021 event, visibility in many areas dropped below 500 meters. In Beijing, PM10 concentrations at one point exceeded 9,000 micrograms per cubic meter. Dust from the Gobi can travel far beyond the desert, crossing China before reaching South Korea and Japan. Particles small enough can even be carried across the Pacific by high-altitude winds. No AA has documented Asian dust reaching North America in around 5 to 7 days. That means a dust storm beginning in the Gobi can change the sky and air quality in places thousands of kilometers away from its source. A whole series of waves appears across the sky. The cloud crests curve forward. In some places, they even curl downward, looking exactly like ocean waves about to break. Kelvin Helmholtz clouds are relatively rare and are not tied to any specific location. They can appear at different altitudes whenever layers of air meet under the right conditions. Two layers of air are moving next to each other at different speeds. The upper layer moves faster than the one below. This difference pulls the edge of the cloud forward. It rises, curls over, and forms a series of repeating crests. When enough moisture is present, the clouds make this movement visible across the sky. The resemblance to ocean waves is no coincidence. Air and water are both fluids. When two layers of fluid move at different speeds, waves can form along the boundary between them. The clearly defined curves usually last only a short time before quickly losing their shape. They do not produce rain, but for pilots, the appearance of Kelvin Helmholtz clouds can indicate an area of wind shear and atmospheric turbulence. The road almost disappears beneath thousands of insects. They crawl tightly together, all moving in the same direction. At times, entire grasslands and residential areas can be covered as the swarm passes through. Mormon crickets aren't actually true crickets. They're a species of flightless katydid found in western North America. When their numbers surge, millions gather and move together in massive bands. Some can stretch more than 10 kilometers long, span several kilometers across, and travel up to around 2 kilometers a day. But they aren't moving only in search of food. Research has shown that many individuals in these bands are deficient in protein and salt, and the crickets right beside them contain both. Individuals that are injured, newly molted, or unable to keep up can be eaten by others. Experiments have also shown that crickets with restricted movement are more likely to become targets, so continuing to move forward also helps them escape the individuals following directly behind. The sun has already dropped below the horizon. Most of the sky begins to darken, but high above, a few clouds remain brightly illuminated. They glow in shades of pink, purple, blue, and yellow. Their surfaces shimmer with colors that resemble mother of pearl. Nacreous clouds form extremely high in the atmosphere, usually around 20 to 30 kilometers above the ground. They appear mainly during winter in polar regions, when temperatures can fall to nearly minus 85 degrees Celsius. Because they form so high above the surface, they can still receive sunlight after the sky below has grown dark. Tiny ice crystals inside scatter the light into different colors. As a result, the entire cloud can glow brilliantly against the twilight sky. Nacreous clouds appear most frequently over Antarctica. They have also been observed in Scandinavia, Alaska, Canada, and the Arctic. But these beautiful clouds have another side. The particles inside them provide surfaces where certain chemical reactions can occur. Those reactions contribute to the destruction of ozone in the polar regions. In bright sunshine, with almost no clouds overhead, dust on the ground suddenly begins spinning into a tall column. It rotates as it moves, pulling sand, dry leaves, and small pieces of debris into the air. Dust devils often appear in hot, dry regions such as New Mexico. They can look like small tornadoes, but they don't require a thunderstorm overhead. In fact, sunny, dry conditions with light winds are often more favorable. The ground heats up rapidly under the sun. The air directly above it warms as well and begins to rise. Surrounding air immediately rushes in to replace it. When that airflow starts rotating, it pulls dust upward and makes the entire column visible. Most dust devils last only a few minutes, but they can grow much larger than you might expect. Typical ones range from around 3 to 90 meters wide. Their average height can reach roughly 150 to 300 meters. Stronger cases can produce winds exceeding 97 kilometers per hour, enough to damage small structures. NASA has repeatedly captured similar columns of dust moving across the surface of Mars. The surface of the lake looks like it's boiling. Bubbles constantly rise from beneath the water, but the water here isn't hot, and there is no steam rising from the surface. Cold Boiling Lake in California gets its name from exactly that appearance. The bubbles are actually carbon dioxide gas. It escapes from underground, passes through the water, and rises to the surface. At the most active spots, bubbles appear continuously. They're small and densely packed, looking much like the fizz in a glass of soda. This makes the surface appear to be boiling, even though the water remains cold. Activity at the lake is also weaker than it once was. Only small amounts of gas now bubble up at a few spots near the shore. The National Park Service describes this as a hydrothermal area that is dying out. So what looks like boiling water is actually just the remaining activity beneath the lake. Offshore, waves rise into walls of water tens of meters high. Surfers race down the face, while their bodies look tiny compared with the mass of water towering behind them. Nazaré is a town on Portugal's Atlantic coast. The nearby waters of Praia do Norte are famous for their enormous waves. In 2020, Sebastian Steutner surfed a wave measuring 26.21 meters here. The record was later confirmed by Guinness World Records. Directly beneath these waters lies the Nazaré Canyon. This deep underwater canyon extends toward the coast. Its shape plays a major role in pushing waves to extraordinary heights. Waves from the Atlantic approach through areas with different water depths. One part travels through the deep canyon, while another encounters the shallower sea floor. Their speed and direction change. The wave systems can converge near Praia do Norte. Their energy combines, causing the waves to grow even higher. Under the right conditions, offshore waves around 10 meters high can grow to nearly 20 meters as they approach the coast. Waves this large don't occur year-round. They require powerful Atlantic swells combined with several favorable conditions. That's why professional big wave surfers often have to wait for the right swell before entering the water. Across a vast, almost empty plateau 7 stone pillars rise completely separate from the surrounding landscape. Some stand almost straight. Others widen dramatically near the top. The tallest reaches around 42 meters. People standing at the base look like tiny dots. Manpupuner is located in the Komi Republic of Russia. 6 pillars stand together in one group, while the 7th rises separately. Their shapes change dramatically depending on the viewing angle. One can resemble a human head. Another narrows in the middle while carrying a massive section of rock above. Originally, there were no 7 separate pillars. They were once part of a much larger mountain formation. Over an immense period of time, wind, rain, freezing conditions, and repeated temperature changes broke down the weaker rock. The surrounding material gradually disappeared, leaving the harder rock cores standing behind. For the Mansi people, this area has long held sacred significance. One legend says the pillars are giants who were turned to stone. Today, Manpupuna remains extremely isolated. The area lies within a protected nature reserve, and access is controlled. One of the fastest ways to reach the pillars is by helicopter. Beneath the surface, millions of sardines swim tightly together. The entire school forms a massive moving body that constantly changes direction. From above, sections of the water can even turn dark because the fish are packed so densely. The sardine run takes place along the eastern coast of South Africa during winter. Sardines move northward with bands of cold water. Large schools have been recorded stretching up to 15 kilometers long, several kilometers wide, and tens of meters deep. When predators close in, the sardines pack tightly together into dense formations. Thousands of fish change direction almost simultaneously. The entire mass constantly contracts, stretches, and reshapes itself beneath the water. People can also enter the water and observe the spectacle at close range. As swimmers approach, the sardines move aside. The school opens a gap around their bodies, then quickly closes again behind them. The sardine run doesn't unfold the same way every year. Its scale and location depend heavily on cold coastal currents. When conditions aren't right, the schools may be smaller or may not travel as far north as expected. Ice doesn't form only on the surface of the sea. In Antarctica, it can also extend straight down through the water. New layers of ice build around the outside, while the center remains hollow. The entire ice tube continues growing toward the sea floor. This structure is called a brinnicle. When seawater freezes at the surface, most of the salt is pushed out. it mixes with the water below, creating a stream of extremely cold, highly concentrated brine. The high salt concentration makes this water denser than the surrounding seawater, so it sinks. The water around it is chilled and freezes around the descending stream. This is how a brinacle grows from the surface downward. If it reaches the sea floor, the freezing brine can continue spreading outward. Ice forms along its path. Slow-moving animals such as starfish and sea urchins sometimes cannot escape quickly enough and can become trapped in the ice. A round cloud appears above a mountain, with smooth edges and an almost motionless shape. Sometimes several layers stack on top of one another. Their outlines can be so distinct that they're often mistaken for flying saucers. Lenticular clouds usually appear around mountainous regions. The wind continues to blow, yet the cloud can remain in almost the same position for a long time. In reality, the air inside it is never still. When wind encounters a mountain, the airflow is forced upward. After passing over the ridge, it continues oscillating up and down like a wave. As the air rises, it cools, water vapor condenses and forms a cloud. As the air descends, it warms and the cloud evaporates again. This process repeats continuously. New cloud forms on one side while disappearing on the other. So the material inside is constantly changing, even though the overall shape appears to remain almost perfectly still. The air currents that create lenticular clouds can also be extremely powerful. Aircraft often avoid the turbulence around them, while glider pilots can use the rising air to reach much higher altitudes. Sand stretches all the way to the edge of the Atlantic Ocean. At Sandwich Harbor, towering dunes drop directly toward the shore. When the tide rises, the strip of land between the base of the dunes and the water can become dramatically narrower. This is part of the Namib Desert in Namibia. The ocean is right in front of you, yet behind it lies an extremely dry landscape. Rainfall along this coast is very low. The cold Benguela current flowing along the coast helps create this contrast. The cold water makes the air above it cooler and more stable. Moisture has difficulty developing into clouds capable of producing heavy rainfall. As a result, in some places, the ocean and desert sit almost directly beside each other. Wind also continuously pushes sand toward the coast. The dunes change shape and position over time, while ocean waves work against them from the opposite direction. These two forces keep the boundary between sand and water from ever becoming completely fixed. Glowing red lava flows straight into the Pacific Ocean. The moment it hits the water, the outer surface cools rapidly and turns black. Above it, thick columns of white vapor continuously rise into the air. In Hawaii, this process has occurred during eruptions of Kilauea. Fresh basaltic lava can reach temperatures of around 1,150 degrees Celsius. When it meets cold seawater, its surface hardens almost instantly. The white plume above isn't simply steam, it's known as laze. It contains water vapor, hydrochloric acid, and tiny particles of volcanic glass. That makes the area near an ocean entry extremely dangerous. As the lava cools, it accumulates into solid rock. As more material builds up, the new land can gradually extend the coastline farther into the sea. But this newly formed ground is often unstable. It can suddenly collapse into the water, exposing hot rock inside directly to the ocean. The water can rapidly expand into steam, triggering explosions that throw fragments of hot rock into the surrounding area. Just beneath the surface, sperm whales can rest in an almost vertical position. Their heads point upward, their tails hang below. Their bodies remain nearly motionless, suspended in the water. The waters around Dominica are one place where this behavior is regularly observed. Several whales can sometimes rest close together. At more than 10 meters long, the group can look like massive bodies hanging vertically beneath the surface. These resting periods are usually quite short. Tracking data suggests that this nearly motionless drifting state accounts for only about 7% of observed time. Each period typically lasts around 10 to 15 minutes. Maintaining the same depth during this time can also be a challenge. Sperm whales may release bubbles to adjust their buoyancy, helping prevent their bodies from slowly drifting toward the surface. However, scientists have not directly measured the brain activity of wild sperm whales while they are in this state. So the vertical posture is considered a period of rest and very likely sleep. Exactly how that sleep works underwater is still not fully understood. A white ring of gas has just escaped from the volcano. The center is hollow. The outer edge curls into a circle. It rises, gradually expands, then begins to distort. Below it, another ring is already forming. These rings can appear one after another at Mount Etna in Sicily, Italy. They're often called smoke rings. But this isn't ordinary smoke. They're made primarily of volcanic gases. The gas escapes from a vent in short bursts. The center moves faster, while the gas near the edges slows as it meets the surrounding air. This difference in speed causes the gas to curl back on itself and form a ring. The ring continues rotating as it rises. Light winds can help it maintain its circular shape for longer. Stronger winds distort it and cause it to break apart more quickly. Etna can sometimes produce many rings within a short period. Their size and speed can also help scientists study the flow of gas escaping from the volcano. Cylindrical rolls of snow lie scattered across the ground. Many have layers of snow wrapped around the outside with a hollow center. They can range from just a few centimeters to more than a meter across. They're called snow rollers. No human intervention is needed. Wind can roll the snow into these shapes entirely on its own. Underneath, there is usually a layer of ice or hard-packed snow. On top, there needs to be fresh snow that is moist and sticky enough. When the wind pushes a patch of snow forward, it begins to roll. More snow sticks to the outside with each rotation, causing the roller to grow larger. The wind also has to be strong enough to keep the snow moving, but not so strong that it breaks the roll apart. The snow that forms the original core is often thin and fragile. As the roller moves, this inner section can fall away. That's why many snow rollers end up with a hole running through the center. These conditions rarely come together at the same time. So snow rollers usually form only during brief periods when the snow, temperature, and wind are just right. Wind can push an entire sheet of lake ice in the same direction. At first, the movement is almost impossible to notice, but once the ice reaches the shore, it has nowhere left to go. The pieces at the front become trapped. The ice behind them keeps moving forward. Pressure continues to build. The ice begins to crack. Sheets slide over one another, some tilt upward, then get pushed even higher by the ice piling in from behind. The result can be massive ridges of piled ice along the shores of the Great Lakes in the United States. This process is known as an ice shove or ice push. the entire mass can continue moving inland. It doesn't necessarily stop once the ice begins piling up. If the wind remains strong enough, new sheets keep pressing in from behind, forcing the ice at the front farther onto land. Only when the driving force weakens does the movement begin to slow. What remains is a chaotic pile of overlapping ice, marking the point where an entire sheet from the lake was forced onto the shore. Even in the middle of summer, a powerful hailstorm can suddenly hit. Countless chunks of ice slam into rooftops and cars, then bounce off the pavement. The largest can even dent vehicles or shatter windows. At the same time, temperatures near the ground can still be quite high. That's because hail doesn't form down here. It develops in the extremely cold regions inside thunderstorms, several kilometers above the ground. Powerful updrafts carry small particles high into the cloud. Supercooled water freezes onto them. If they remain suspended long enough, additional layers of ice continue to build, making each hailstone larger. Eventually, they become too heavy for the updraft to support and fall toward the ground. That's why a hot summer day and freezing hail can occur at the same time. In fact, hot, humid conditions can help fuel the powerful thunderstorms needed for hail to form. A sky like this can easily make it look as though a massive tornado is approaching. Dozens of rounded clouds hang downward, swelling into individual pouches packed tightly together. But these pouches don't mean a tornado is about to form, and they aren't falling toward the ground. The changes are happening directly beneath the cloud layer above. Cold air containing water droplets and ice crystals sinks downward. Sections of the cloud descend with it, bulging below the surrounding cloud base. When this happens across a large area, dozens of pouches can appear at the same time. These are mammatus clouds. In the United States, they're often seen around large thunderstorm systems, including those across the Great Plains. But there is still no single explanation for their distinctive shape. Several physical processes may be involved at the same time. Scientists are still studying exactly how each pouch develops, maintains its shape, and eventually disappears. After everything we've just seen, Earth may be far stranger than what we're used to seeing. From the sky and the ground to deep beneath the ocean, nature keeps creating moments that look impossible but are completely real. Some last only a few minutes, others return with the seasons, and some are so extraordinary that seeing them once is enough to remember them for a lifetime. So, how many of these phenomena did you already know about before watching this video? and which one surprised you the most? Share your answer in the comments. If you want to keep discovering the strange things that actually exist on this planet, don't forget to hit like, subscribe, and turn on notifications to join us on the next adventure.